Hello friends, and welcome to my GURU2 Basics tutorial, produced for the Farm Facilities Summer Radar Institute 2023. My name is Trevor White. I designed and developed Guru, and I guess without further ado, we'll just jump right into it. When you first boot the software, you'll get this splash screen while GIS layers are loaded and various things are initialized. You'll get the console pop up, as well as the main window. I'll get this sized sensibly here. So chances are good you'll get some view like this when you first boot up. To move the map around, just click and drag with your mouse. You can scroll up and down to zoom in and out. The base map covers the whole world with, I don't know, pretty basic land area and waterways. There's basic roads included for the United States, but as we'll see later, you can bring in your own GIS layers as needed to contextualize your meteorological data however you need. So to start off with, I guess we'll just load up some data. Generally speaking, you do that by just dragging. I've got a folder full of data over here, and I just drag a sweep out. Initially, when you first load a sweep up, you'll probably get this set product prompt. That just tells you, hey, need to right click, go to the product menu, and choose one. With a lot of products, you'll get a view that looks something like this to start with, because return power in this case, is like minus 109 up to like minus 50-ish. So obviously doesn't cover this whole plus or minus 84 range. So to fix that, you can open your palette menu and the context menu from right-clicking in your data frame, and you have these sliders that you can change. I usually just use the auto range function. Sometimes if there's a bad value in a sweep, it doesn't always work. But you can even punch values into these text boxes, and those will affect the color palette values. Going into the just more anatomy of the GURU2 display, you have your legend over here, obviously. There's a dataset description up here showing your time, your sensor, which dataset slice it's on. In this case, it's a tilted polar coordinates radar sweep, but you might have derivative gridded data, for example, so you'd see a number there in meters. Up here, you've got your product description label in the upper right, and the lower right, an explanation of how far apart your distance ticks are. Here in the upper right, even further, we have the metadata tab. That'll tell you what radar you're looking at, basic information, Nyquist, frequency, maximum unambiguous range, defined radar altitude, latitude, longitude, and then a bunch of very dataset specific items below. So we've got the whole volume time, the sweep time, and then rather importantly, the beam time. So we know, depending on where the mouse is, we actually know when that beam was collected. You've got in here are ray statistics specifically. So your defined azimuths here, those are the azimuths defined in the file for given rays. The azimuths and latlons down here, those are, well, the latlon's not, but the azimuth is defined from your radar, whatever radar you have the data set up for. But it's just a purely continuous azimuth. The one up here kind of kerchunks as you mouse across beams. Gives you information per gate, like range, altitude above sea level, and radar level. Ray, gate, and sweep, like index numbers, cut number, as well as the raw tilt angle and kind of a corrected tilt value that we use sometimes for when a radar dish is pointed partially toward the ground. So if part of your half-degree beam is going to be clipped off, say in this 0.45 degree sweep, then so we'll be losing a small portion of a 1 degree beam elevated at that elevation. It gives you a rough idea of where the center of your remaining power is left, and then of course obviously your the data value that's under the mouse. So under all these various menus, various functions. Oh, also up here, there's your perusal window, I guess, or perusal tab. Let me load up some more data so I can explain sort of data series versus data bindings a little bit. So I'm going to queue up these 27 more files from DAO 6, and you'll see this prompt come up. This is because I've already loaded some data from a sensor that shares a name with something I've already loaded. Or I got that backwards. I'm loading files for a sensor I already have, is what I mean. So in cases like this, you can either choose to put it in the same bucket, or you can create a new bucket. Generally, I just always put my files into the same data series because, for most cases, you'll want to have your files from a given radar in the same bucket. But say you're doing something kind of exotic, like, I don't know, comparing two severe weather outbreaks that happen to be observed by the same radar, be it a DAO or an 88D, because the two outbreaks affected the same geographical area. You would be able to split those groups of data apart and interact with them separately as separate logical buckets. But we'll just load this into the other bucket. So as you can see, we got the files out of the decompression queue. They're processing through the data file ingestion queue, and as they do, you see this data file layers in flight number changing. That'll jump up to like 20 plus each time you start loading an 88D volume, for example. Just sort of gives you a basic idea of what's going on under the hood. And then over here, this little perusal tab lets you select data sets based on the various files you loaded. So we can see these all these various sweeps from the 2 volumes for DAO 6. So let's see. This application data button can be pretty useful because it gives you access to the application data files that GURU depends on, which you can get to your configs if something breaks. You have access to your deployment layouts if you want to copy something out manually. Exports, those are quite important. All your GIS layer packages. Logs, which ideally you'll never need to send me, but I always appreciate them in case of bizarro crashes or bug issues. A folder of color palettes, your live data polling folder, the folder where layers are staged, don't need those. And lastly, a file for national elevation data set terrain files, but that's for a number of unfinished features. So I guess I'll just close that for now. And let's see. So I'm going to pull up a second panel here. So under the panels menu, you can choose to define your data frame layout by one of these can settings or by a number of rows and columns, up to 4x4. With this custom option, you can also define like panels that aren't all the same. They're not congruous, I guess would be the correct term. So for example, one panel's big and the other panel's very small, or one to accommodate like a chat window if you're using my fleet management API. But for general purposes, the canned options usually work pretty well. So to attach a group of data sets to one of these data frames, you can do that under the data menu with this attach data bindings option. And you can see like you can like it's a mirror of these panels here. So if I'll just go ahead and load DAO 7 because why not? We'll go with a cute 4-panel setup. Pull up 7. I'm just going to load them all in at once because why not? And we can see that they're going through decompression. Then they'll there you go. So now these 2 unassigned panels have been attached to the new data series by way of the default data binding. And I guess before I go much farther, data series, sort of abstractly, is just a bucket of data. A data binding is some kind of it's a connection to that data. It's a cursor that allows you to determine what data set is selected, because obviously Guru will let you load data from multiple sensors, and it logically separates them. And having this framework wherein you can attach one or more cursors that you may control or synchronize with one another to the various data series gives you a really large amount of flexibility in terms of what you can possibly do. So let's see, I'll just go ahead and select product. I'm going to make this velocity or quality controlled velocity rather. So ta-da, here we go. Sort of your classic dual Doppler data set here. Let's make these velocities look a little better. So with these panels, obviously they're all in geographical lockstep right now, but they do not have to be. So if you look at this viewport option under the right-click menu, you have this clone current option. That will clone the entire collection of quote-unquote viewports for a given that a given panel is using. And there's viewports for each data set topology. So geographical data sets like radar data sets like this that are georeferenced and make sense to view on a map. Those all share a viewport. RHIs have a viewport reserved for them, as do airborne tail Doppler sweeps. But so when you clone the entire collection, you can move a given panel independently. But so I'm just going to keep these all in the same viewport. So, okay. Further down the context menu, we see data binding options. So we've got a bucket of DAO 6 data loaded at the moment, and also a bucket of DAO 7 data loaded. And if I just change the binding, we can see we'll still get the same product if the product's available, but we're getting it from that different sensor. Synchronization is a super useful feature. So as of right now, so I'm controlling the DAO 7 data binding, because you see the name DAO 7 up here in the upper left. So when I hit the arrow keys, I'll just be tapping through that volume. But if I want to move both radars simultaneously, I can synchronize them. So whenever I move DAO 7, DAO 6 will also update. So it's gonna choose the closest data set in time, so as to get you the most analogous view from your other sensor. There's a number of like interesting binding options you can use. Obviously, like you can select them from that menu. That's not particularly useful. You have the option to synchronize low. So when a synchronization signal is sent from another binding, so say I'm controlling 7, DAO6 is going to want to use the lowest level sweep in each volume. Because each sweep is its own volume right now, it's going to just more or less track 7. But if you were looking at, say, 88D data, or I guess I can try to make some volumes out of the DAO6 data via my handy-dandy volume making window. So it'll select only these like 0.45 degree sweeps. It's just trying to select the sweeps that were collected as the intentional low level ones. Generally, I think the logic in my code is just whatever in whatever given volume to select whatever is the lowest defined fixed angle. In this case, it's 0.45. I see there's some overplotting going on. There's an option to fix that, which we'll get into later. For now, I'm gonna unvolume these. Okay. So moving on down the line, obviously you've got your product menu here. You can also filter by a given moment and a given relationship, but I usually just do a greater than. So I'm controlling the binding for DAO6 right now. So whatever data viewport or data frame is attached to this particular DAO6 data binding, it will have this filter applied. If I say added another DAO6 binding and let's see, assigned it over here, then that one's not going to be filtered. Because filtering is binding specific. Let's see, we'll switch that back to none. I'm also going to move back to the other binding. Okay. Let's see. I guess you can extract RHIs or like pseudo RHIs out of completed volumes. That can often silently fail depending upon what the situation is with the sweeps that have been joined into a volume. If that happens, it would come up on the console. Of course, what I've got going on there is just some stack traces for my renderer. But probably the most impactful for this particular situation is the add to deployment option, which will take your current radar with its current coordinates and add it to the operational deployment layout, which I'll open the window for that here in a moment. So I'm going to go ahead and add both radars to this deployment, and then go into the operations menu and click deployment setup. So you'll get this menu or window, and you see I've got two radars here, and they also are reflected in my dual Doppler coverage over here. So what you can do is just click one, hold down Control, click the other, and say go. And as long as your deployment overlays are configured to be seen, you'll get these dual Doppler coverage indicators. Once I have those, I generally will turn off my indicators of where my radars are, because when you're looking at radar data, that tends to be pretty apparent. But so here we can see we've got just a wonderful dual Doppler case. As I'm sure many of you know by now. Let's see. I think that's more or less it for the right-click menu. That would be my dog sneezing in the background. Okay, so for general use for making plots, I find it can be useful to use this save view option. So you can, I've got two sets of viewports defined right now, but the one we're using is viewport 1. So when you do that, you'll get this option here. I'm just going to call it test view if I can type. And then if I don't know, go elsewhere, somewhere in the North Pacific, I can just recall that test view into either of my viewports and just bring it right back. So if you're making plots for a given case study and you think you're done but want to be able to come back in the future and make plots, that's a feature to use to make sure you save that view. Speaking of loops, or generally exports, I guess I'll just export like a quick screenshot loop. So what this will do is just go through all the different data sets and I mean, more or less, it just takes a screenshot at every time step. It does some fancy behind the scenes things, but that's the important punchline. So once it's done that, you can go into your application data, and let's see, exports, and bam, there you go. There's some 4-paneled screenshots of these various data sets. Okay. So in terms of, let's see, the data menu. So let's say we want to just look at, we just want to focus on DAO 7. We can say show on all frames, and that'll just, for us, select the top products. So I've got, raw velocity, return power, normalized coherent power, and spectrum width. With some fascinating color table choices on my part. There are other types of data series that you can create, notably live data series, which are more or less the type of data series we're using right now, wherein every data set that's loaded is resident in memory, accessible so that you can use it in some kind of analysis, whether you're using some kind of future tool where, I don't know, it's a dual Doppler or something, or you're just, I don't know, taking cross sections of grids. Live data series, on the other hand, those just maintain a certain number of layers maximum. So at some point, once the data series fills up, it'll start dropping data sets off the front end to accommodate newer ones. There's our radar data baked in. There's MRMS baked in, as well as GOES 16 and 17. I guess I can I'll just load up like a mesoscale sector to illustrate that. So let's see, moving on. These so this these menu items up here each reflect a data series, and it's a mirror of this manage data series menu down here. I just wanted to make these more accessible. Probably at some point this manage data series menu item will go away. But okay, my data set's loaded. So let's go to one panel. Let's go to, yeah, there we go. There's a current picture from the fancy space camera. This is my RGB infrared sandwich satellite product. But to just make sure this data binding is selected so that when I try to loop this, it'll actually loop, I just double click. And it was selected, but now we can see that Goes East Meso 2 is up here. So I can play it, and yeah, there's atmosphere things happening. So there's a little tower going up there. Cute little storm west of Bridgeport, Nebraska. So let's see. Probably one of the more useful things that I added originally as part of alpacas. I'm sure you've probably seen that up here. Alpaca stands for Adaptable Lightweight PHP API for Coordinated Atmospheric Studies. While GURU is my life's work, I would say that acronym is probably my greatest achievement. But that's just our fleet management, kind of logistics, communication, situational awareness API that can integrate with GURU. It also theoretically could integrate with whatever, provided I release some kind of public documentation. But so you can add radars to your deployment layout by clicking the appropriate button and then adding it. You can draw, which is fun. You just use the pencil to scribble, and then you can right click to release it and get back to drawing on your map. And the lines do stay constant with the thickness they were when you originally drew them. So yeah, you can do all sorts of stuff with that. Those are shareable via alpacas, but generally it's just for tailoring screenshots to your liking. Okay. Back to the operations menu. There's also other assets we can add to the deployment layout. I guess I'll just go ahead and show all of these items. So we have like mesonet vehicles, like here's a pretend Scout 3, non-mesonet vehicle like a sounding vehicle, and pods. Let's see. There we go. Okay. And I guess sort of last in terms of the general functions that you want to be interested in. The palette settings window, that's a little bit esoteric. You'll notice that, is there anything in here that I've defined twice? Yeah, so there's 2 carbones in here. Those, the challenge that I had with color palette definitions is that operators of research radars don't generally use the same names for the same products, and also rarely have the same collection of products in their sweeps, and also with different bands of radar, it can make sense to create 2 instances of your reflectivity color table, and split your 2 radars into separate color table paradigms. For example, with cow, it's C-band as Steve went into. The scattering regime is obviously quite different there, and you most likely would want to split up your C-band and X-band radars onto different color tables. And in an ideal setting, you'll have the varied product names to be able to do just that. So in this particular case, I've got velocities mostly here assigned to this copy of Carbone, and then some row HV assignments that I believe are being overridden by this I guess default, yeah, this default row up here. So if there's any instances above the instance that you're modifying, it'll be superseded by the one above. So to instantiate a color palette, you'll just select one over here, click the right arrows to bring it over, and then you just type your assignments into the box. Settings are updated when you hit OK or when you close the window. I think even if you hit cancel, the settings are updated. So, yeah, mean it, I guess. And then also of relative import is this general configuration window. Here you can set your font sizes. This base magnification setting it is not yet implemented. I need to do a little bit more thinking in terms of where in the text rendering pipeline that needs to be applied. But these other base sizes, I've set these to substantially larger than was default. So things are more readable than they otherwise would be. These Ray QC options are quite useful. I don't have any of it turned on right now, but if I had DORAD turned on when I loaded this data, that overplotting that we saw on the uppermost sweep of Dow 7 at the end of the radar volume, as the antenna was finishing up the volume and slowing to a stop, those rays would have been culled. Let's see, and then this is some very much like internal facility stuff. There's basic support right now to connect Guru to a stream of radar like time series, the base data, the rawest of the raw. But as of right now, that only works for feeding data into the solar alignment tool. And the utility that provides the data isn't currently packaged in the Guru release, but will be at some point. Okay. Let's see. I think I will go back to 7. Just to illustrate this, not palette settings, general settings. Turn on DORAD Ray QC. And then I'm going to try to load a sweep twice. Yeah, okay. So I'm going to put this in a new data series to make sure it loads. I think otherwise I reject it. You can see here in the console, there were 838 static rays that were removed. And then there were, let's see, 37 that were significantly off the calculated tilt angle of that sweep, and then 322 that didn't meet any of those previous criteria, but were extra and were otherwise like overplotting. So if we go to the data binding for this second Dow 7 data series, we can see we have this nice, what is this, a 16-degree sweep with absolutely no overplotting. So there you have it. I guess to get to some newer features of Guru, let's load up some really old data. We're going to go way into the past to about 25 years ago to Spencer, South Dakota. Hopefully these sweeps won't take too long to load. Let's see, I'll do 2 panels for this. Then we're going to take Dow 3 and, nope. We're going to take Dow 3 and show it in all frames. We're going to look at, let's look at power in both, actually. Okay. So here we see the Spencer, South Dakota tornado shortly after it had unfortunately impacted the town of Spencer. What I want to highlight here, though, is one of GURU's newer features that allows you to restrict the type of data set that a given data binding will select. So in this data series, we have a single, rare, tornado RHI from the early Dow days, and 2 volumes of just standard PPIs. Obviously, if you loop this, it's very disruptive, and in my opinion, completely unusable. So to fix this, what I did is enabled data binding restriction by topology. So if I add a second data binding to this Dow3 data series, and then I attach it over in my right frame, and then also synchronize it with the other Dow3 binding, I can say only PPIs over here, and only RHIs over here. And what that'll do for me is allow me to control this binding on the left and not see this RHI that pops up in the middle. I believe there is a complete volume of RHIs that was taken between these 2 PPI volumes. So we're missing a little bit of time here, but this is what I had in my collection of GURU test data. Clearly the Spencer tornado is sort of sagging southeast, and at some point crosses over the azimuth that upon which this RHI was collected. We can see here it's kind of cutting through the core. Then there's this gap, and then we start to get into the tornado. You see this. There's your weak echo hole there in the tornado. And of course, we're quite tilted. So one place that I really like to emphasize GURU features is in the realm of GIS. GURU, as I was going to explain in my PowerPoint, stands for Geographical Unified Radar Utility. So critically, I want everything to be able to be on a map if possible. So what I'm going to do is import high-resolution road data for these 2 counties. These are, if my memory serves, Hanson and McCook counties of South Dakota. So under this GIS menu, we have a number of things. So first of all, you can pick and choose which of the shape files you want to have currently shown. Each shapefile can have multiple different feature layers pulled out of it that are all styled differently. So say I had like one unified U.S. roads shapefile, and what I could have pulled interstates, U.S. highways, and state routes out of it and have those be separate layers at this level in the hierarchy. So, in addition, there's user-definable place marks. The cities and towns database is static right now. It will be replaceable in the future. You can put in custom place labels. So if I'll just use this lat long here in the bottom. We'll call this test, except with capitalization that isn't weird. 43.65 and -97 point. We'll just do 2.8. Good enough. So here we see that test point will show up. So that's kind of nice to label various things. These will stick around across software restarts. They're stored in your config folder. Annotations, unfortunately, do not. Their primary purpose is to be shared over alpacas. So once an annotation is sent, it's archived online, but it's not stored in your configs or anything. Let's see. just going to get rid of this. Then also on the GIS tab, GIS menu, you can turn on and off this distance scale if you, for whatever reason, do not want it. But what we're dealing with right now is this GIS layer management window. So, say you want to just contextualize this tornado in terms of the road network and, by proxy, the type of land cover and sort of probable number of structures that were impacted. So to do that, we're going to just browse to, let's see, where did I put everything? Should all be on my SSD. And let's use this 2010 survey. So once you've browsed, you've got this file path here. You click import. It'll do a cache update. Blah blah blah. I'm also just gonna do the other one real quick. Again, getting lost in my own SSD. Okay, so we've now just imported the shape files, but they're not really going to be doing anything. Internally, Guru has kind of defined GIS layers. These I've defined myself, and I distribute them as sort of the basic ones that come with the software. But I just have these 4 broad categories: roads, political boundaries, waterways, and land. Individual shape files are assigned to these GIS layers. And then any extracted sets of features will be under these shapefiles. So we definitely want our roads to be attached to roads. So we're going to go ahead and just assign these, and we'll, after selecting roads up here, we just go in here, select, and then we can assign. These do not yet have any extracted features, so we'll do that next. So to do that, you'll go back to the Features tab, select your shapefile from this dropdown. And this is sort of my really clunky way of selecting geometry out of a shapefile with some degree of precision. You can select everything. That's what we're eventually going to do for these. But I also have these this method of using the values in the database file that comes with the shapefile to select subsets. And to help do that, I provide this drop-down of all the different attributes, and then this preview unique values button that tells you, okay, what's in the table. So in this case, we know this is state FP, so it's the state FIPS code for South Dakota. It's 46. County FIPS is 061 for this particular case. Obviously, IDs, there's going to be a good number of them. You could, say, select a particular road by name if you wanted to. Mostly what I use is a combination of this RT type value, which sort of like interstates, major roads, collectors, primary, secondary. I forget what the particular letters stand for, but it's all well documented on the Census Bureau's website, which you'll have hopefully been at if importing this type of data into Guru. And then also this MTFCC value, which is a more specific type or more specific identifier of what type of road we're looking at. So whether it's an on-ramp or a controlled access highway, and so forth. But as I said, we're just going to do them all and create a single big layer called all. So now we see that pop up. Then we'll just go to the other one. Again, just select all, create it, and now we have these 2 counties as road layers. Critically, you cannot use the other Guru window if the shapefile management window is up. Just FYI. So these individual feature layers can be styled. As you've seen, my different roads pop up at different scales. That is definable in these two boxes. So it's a minimum of 1 to whatever, and a maximum of 1 to whatever. That's the geographical scale. It's if you use the 1-inch tick marks on your computer screen as a guide, you'll be able to calculate those scales pretty easily. They have configurable foreground and background colors, so let's just make these all red, and let's make 23 is a bit much. Let's make that 2, that 4, and we're gonna make the background partially transparent. And we'll go do the same thing over here. You do have to click the apply button to make sure things apply when you're modifying the colors here. I think I set this at 126 over there. I'll actually make this much larger so you can see that it is indeed partially transparent. Wrong window. So there you have it. That's kind of a majority of the things that Guru will be probably useful for doing in the context of Summer Radar Institute things. Hopefully you all have my contact info. If not, you can get it from the email chain or my Illinois email from Steve or whomever. But yeah, have fun. I always want suggestions on Guru features. I once got a bunch of people together who had used Guru a lot over a number of weeks and just begged for feedback, and like the best I got was make products easier to get to, which is something I definitely want to do, and I'm still looking for active feedback on a good way to do that. So yeah, and the GIS layer management system, that was the result of a user suggestion from many years ago. So yeah, let me know if there's any features you want to see. Let me know if you have any crashes that you run into. Oh, speaking of which, let me just show the crash handler. So first of all, there's a bunch of different console commands. There's you can list the active threads in the software, for example. You can kill them if you really want to. You can list your various data series. You can for the purposes of Mosaic, you can tag them with various things so that you have manually tagged data series that are presumably of like type, but you can sort of many things can be kind of forced in a console. But in this particular case, what I'm going to do is force a crash to show you what pops up when Guru explodes. So this is my little crash handling utility. If you're willing to, I always love an explanation of, hey, if something's broken, what were you doing when that happened? And then this stack trace, if you click send, that will be sent to me. And I plan on actually doing a cold read of all of those at some point. That'll probably be pretty humorous. But yeah, thanks for all your help. I hope you've been enjoying the week, and I hope to see you all again.